Thanks, Ron. So has anyone tried the CTF yet? No? No? You all have way better things to do than like listen to talks? Dave did? Okay, thanks, Dave. So the CTF is a little something I had floating around. It's not your usual thing. It's built primarily on the stuff that I'm going to kind of talk a little bit about. So I'm here talking about cloud. Cloud. My name is Mike, as Ron mentioned. My background is in math. I do cloud architecture and cloud development as a day job. And my colleague, who refuses to activate his Windows, Travis Friesen, mentioned me last night and threw some shade. So I'm the well-dressed short guy at the back of the room. And I work with him. I'm the cloud specialist for Flying Fortress IT. So that's who I am. I'm talking about primarily Amazon. That's where my deepest technical skills are. But pretty much everything I mention has an analog in one of the other major cloud providers, of which Microsoft and Google are the other two. So that's enough about me. Quick survey. Who here has used cloud? Personally, professionally, I expect pretty much every hand in the room to go up. Cool. Who uses some kind of public cloud for work on a roughly weekly basis? Awesome. Who interacts with that cloud service on a roughly weekly basis as part of their day job? Good. Roughly the same number of hands, but a quarter of the room. Who is directly responsible for either architecting, developing, or maintaining that service that runs on a public cloud provider? Not bad, but it doesn't. Cool. So that's really good. So for those of you that either don't use it or are looking to avoiding moving to public cloud providers or that kind of stuff, thinking about why is going to be help. Totally welcome questions. I have some prompts at the end because I like to salt my audience. But if you have your own questions, those are even better than mine. So everyone here wears a handful of hats. Maybe not this many hats, but you wear a bunch of hats. Either you're a designer, you're a developer, you do operations, networking. We've got a bunch of networking folks here. Either your solutions architecture or your business or your sales or your creative. Even if cloud just totally vanishes in like 5 years, it's unlikely that it's going to vanish in one. So right now, it's a valuable service that we're taking advantage of, and knowing how to do it right is really important, even if you don't keep it long term. So that's sort of what's going on here. People who are avoiding getting on it for a variety of reasons, thinking about why, and getting answers to those is going to be really valuable. And there are certain people that can help you out with that. So I'm going to talk mostly about things like, man, PowerPoint can do better with this. Sure, whatever. So I'm not talking about things like Office 365. I'm not talking about things like G Suite and Salesforce. I'm talking about Azure, Amazon, and Google. The big three. The rest pretty much just don't count. There'll be a couple different flavors of Kool-Aid, but mostly orange. So we know how to do security. Everyone in this room knows how to do security, right? Even if you don't do it. I think it was Jared that told me this joke. How do you know when you're connecting to a critical piece of network infrastructure? You get a certificate warning. Let's Encrypt is free. Like, why doesn't this thing have a legit certificate? Oh, well, because. So we know how to do security. We encrypt stuff. We use proper credential management, key management, password management, strong passwords, endpoint management, patch management, network visibility monitoring, backups, and just general compliance stuff. Like, we know how to do on-prem security. So when people go, oh, the cloud is not secure, okay, let's talk about why. So when things live on someone else's disk, someone else's network, someone else's computers, of what I just listed, what can't we do there? What do we lose when we lose that control, the ability to go and actually touch and hug our server racks? Well, I mean, we can no longer hug them, if that's your thing. I know Jared likes rack jockeying a bit, so maybe that's his thing. Sure. He's kind of weird. We lose some of the really low-level stuff. Or in a lot of cases, we move for cost reasons to multi-tenant architecture. So we have a direct neighbor we don't know about, and can't control. So that's one of the big things, but there's a couple others. We don't control the hypervisor for those of you guys with VM hosts. So that's maybe a thing, or maybe that's a good thing. So it turns out it might actually be a whole bunch easier, better, faster, and cheaper with some, I don't know how to air quotes, a star, but this is a star, depending on how you define cheap and whether or not you value your time. Right? So if it's non-incremental to the budget, and you're like, oh, well, Bob's already spending 8 hours a day doing this, and if we ask him to spend another 2 hours a week doing this, he's not really going to matter, and we're not going to pay him any more for it, so it's free. Okay, sure, that means you don't value that time. So depending on how you define that, that may or may not factor in. Things like, who here knows which version of MySQL they're running or other SQL server? Off the top of their head, exactly which version? Great. How many of those are at the latest, most patched version? I think one hand, maybe two, went up out of about a dozen. So, this is a great example of things like, if we're not patching our servers because people can't be bothered, can we just pay to make that happen? So we're going to talk about the pillars of security, the things that we're typically, we've seen these before: availability, confidentiality, integrity. I'm going to throw a fourth one here, which is trust. I'm going to talk about that one first because all of these decisions that we're going to make, all the stuff we're going to talk about, has a foundation that's somewhere in the trust realm. So we're going to talk about trust. So for this talk, we're not going to worry about the vulnerability of my firmware. We're not going to worry about things like Broadcom, Samsung, Intel stealing my bits. We already trust Linux and Microsoft and Apple, and we trust Zen and VMware and Microsoft for our hypervisors and all sorts of stuff. So we're going to kind of avoid the extreme levels of owning your own gear, and we're going to talk more about the realistic stuff because we live in the real world. And that means that we have to be intentional and deliberate about how we evaluate trust. Who do we trust and why do we trust them? And that's going to tell us things that are really important to us. Note that, so this is a really nice graph. It's kind of dim, I don't know if you'll be able to see it, but it takes trust and breaks it up into long-term, short-term, and deep and shallow. So an example of long-term, shallow trust is the trust you have in your government. I don't have a choice. I kind of have to trust them to do something because they're going to be doing that thing anyway. I can either move to another country and choose to trust a different government, or democracy, sure. An example of temporary deep trust is going to the doctor. Hey, my face is melting. Tell me what's wrong with my face. Don't go to Google and say, why does my blank hurt? Go to your doctor and ask that, just while we're on the topic. So who do you trust? Well, I trust Safeway not to poison my food. Right? Now, why do I trust Safeway not to poison my food? Well, for one, it's illegal, but that hasn't stopped companies from doing things before. So who here has a vendor they trust implicitly to give them good stuff, patch it on time, and do things right? Toss one out. Who? AWS. Palo Alto. Sure. Palo Alto. Okay, we'll take Palo Alto. That's one idea, right? So depending on what you're using from them, you may look at that, some people look at that and go, great, they do great stuff. Some people may look at that and go, great, they do, it's not bad. It's not bad. But evaluating why you trust them, what you trust them to do is really important. Flip side of that is, who don't you trust? Who has a Sears appliance? Great. Who bought the Sears extended warranty? My hand's not up. What has Sears closing done to people's trust in that kind of appliances, like that kind of service, right? So trusting versus non-trusting is really important in how you make decisions. What if there was a way to, verify that these people were doing what you wanted them to do? I think we call those audits. Who loves audits? Who loves receiving audits? I should be clear. All right, okay, great. So one guy, you are a masochist. The rest of you are sadists. That's how that works. So audits are how we look at something and go, hey, good, you say you're doing that's awesome, I like that. Audits are how we look at that and go, prove it. If you're PCI DSS compliant and you go through a customer audit, that's them basically verifying that you're not screwing with stuff. So now I can actually talk about fun stuff. So what if you had a large portion of your auditability requirements as a service? So I'm going to go through 5 services that Amazon provides that allow you to automate a large portion of the workload that's typically required in being subject to an audit. So the first one is AWS config. Who tracks infrastructure changes? Changes made to infrastructure go into an auditable log. so you can see those. One hand. It's a great idea. Literally a service. You just pay money, and it's basically free. On a $15,000 a month Amazon bill, this costs $5. Every hour it logs the entire or incremental version of your entire infrastructure for all supported services to a JSON document, signs it, sticks it in a bucket. Like it's literally just something you pay for. So something that no one in the room has except for one gets this, you just pay. You just check a checkbox, boom, done. So that's the kind of thing that you can get here that's why that slide said maybe easier, faster, cheaper. It's this kind of stuff. Next one is Amazon Inspector. So Amazon Inspector lets you evaluate your current state against a bunch of different best practice. So it'll let you do things like, Linux patch management, application patch management. It comes with its own rules to evaluate against both open source tooling, closed source tooling. What's your Oracle management software patch level? Did you do the recent patch that came out 2 weeks ago? That kind of stuff. You can also write your own rules to say, hey, our application that we write internally is subject to these vulnerabilities. We want to make sure that old hosts that are spun up via developers never spin up with a version less than X. You can do that with Inspector. Again, just something you just check a box and away you go. Trusted Advisor is very similar, but audits you against AWS-specific best practice. So things like cost optimization. So you give it access to your resources. It goes and looks and says, hey, all these VMs are basically idle most of the time. Or they're saturated, but you could purchase reserved instances and save 50, 30, 70%. Take your pick. These idle resources, can you turn them off? So it'll actually make suggestions of that as long as things like open S3 buckets. Good. This will tell you that's a horrible idea. Don't do that. So I counted 13 S3 bucket leaks, all of which would have been very, very obvious had they just turned on this box. The entire feature suite for this costs $100 a month or 10% of your Amazon bill, whichever is more. You literally just turn it on and away you go. You can get the basic checks, which include open S3 buckets for free. CloudTrail is my favorite thing ever. CloudTrail is how I'm monitoring what you guys are doing with that CTF endpoint. CloudTrail logs almost, asterisk, every single API call you make to an AWS API endpoint, logs them into both a real-time stream, which you can do then actions on, like alerting, triggering, performing automated actions on any kind of API call. It then also collects them, and once every 5 minutes or so, dumps them to an object, signs the object with an Amazon-specific private key that they make the public key available, so that, let's say I'm an attacker, I make an API call to open up a bucket policy so I can access these S3 objects. That API event is collected by Amazon and goes into an auditable, secure record that I, as an attacker, can't change. Cryptographically, it's signed. Like once the log gets to me, I know whether or not it's been deleted or changed. This is by far my favorite thing. If you've never seen a CloudTrail event log, super cool to watch just everything fly by. And then AWS Artifact. So I talked about auditing. If I'm, if my goal is to be PCI DSS compliant and I need to provide something to my auditors that say, hey, we're using Amazon for these services, and these are all PCI DSS compliant services. I sign an NDA with Amazon, my account manager. Yeah, that's either the cable or the projector. Anyway, Artifact is a self-serve. So once I sign the NDA, I get access to that. I go, check. I need these audit reports, these compliance reports, and I go download, and I just send that off to my auditor. And that entire section of my audit requirements is done because of the shared responsibility model I have with my cloud provider. I just go, hashtag not my problem, hashtag literally, here's the attachment. So these are services that are offered by Amazon that really change the way that you address a lot of this kind of stuff. They let you choose a root of trust. If you don't trust Amazon, you don't trust Microsoft, you don't trust Google, that's totally cool. An audit that they've had done against them, certifications, validations, attestations against them, you can use those to augment your root of trust or give you an alternate root of trust. So you don't have to trust them directly. You can say, oh, well, these other organizations, or they've passed these certifications. Oh, okay, I trust those. I know what goes into them. I've done it maybe. So I trust that, okay, yeah, these services are actually being done the way they're supposed to be done. So that's what this gives you. In addition to making your life easier, it gives you some trust in the provider itself. Availability. So availability is one of the main 3 pillars. If you can't get access to your stuff, it's as good as not being there usually. Ask the National Health Service in the UK what it's like to not have access to medical records. Yeah, I'm glad that wasn't me. So I'm going to talk about stuff like at the edge. Who uses a CDN or runs large web tiers? Couple, half a dozen or so. So the edge is where all the weird stuff happens. Weird stuff happens at the network edge. And life is way easier if you can just not do that. So WAF. WAF is an example of something you can get with AWS WAF. It's literally a service. You turn it on. It integrates with your CDN edge, and it protects all of your stuff. Just like Christian talked about yesterday with Fastly and their WAF, same general thing, but it means you can turn it on for any kind of web property because it's billed per usage. Really simple. API driven, you can integrate it with CI/CD pipelines if you're a developer. Oh darn, this old version of our web application that we can't deprecate is actually subject to these vulnerabilities. Make a WAF rule for it, wrap any of those instances of that application in it, and now you don't need to modify code to fix those vulnerabilities while you're busy deprecating it and getting it the heck out of the way. It's configurable and sits in front of a whole bunch of different resources and gives you visibility into them. So it doesn't have to block traffic. It can actually give you an insight into what's going on and what the traffic actually is. I'm going to get lots of time. It has pretty good and a pretty wide range of stuff that it can do out of the box. So it can filter SQL injection, cross-site scripting, IP and geo blocking. It can filter by request size, string matching, request headers, request limiting, and others. It's basically flexible DDoS mitigation in a box. And you can apply it to literally any origin if you want. You can even shoehorn it in front of an on-premise application. Kind of neat. And it integrates with a bunch of other stuff. You can actually get an OWASP top 10 configuration policy you can apply to a WAF, and then just apply that to your web application. And OWASP top 10 is basically a checkbox now. So that's really cool. We heard really cool talk from Mr. Theo about DDoS. Sort of. He talked about DDoS in his talk about other things. So DDoS mitigation is hard. What's the best way to mitigate a DDoS attack? Have bigger, more diversely routed pipes than the bad guys. Good. Thanks, guys. You're great at this. I like this. So Amazon provides DDoS mitigation both through two of two products. So the orange one here, that's the icon for CloudFront, which is Amazon's CDN. You can shim CloudFront literally in front of everything. You can put it in front of an on-prem web server that's hosted on one instance. And there's actually a really funny story I heard from someone from Amazon, which is they got a call one day from a customer who was using a different cloud provider. Not Amazon, a different cloud provider for their web tier. They're like, we're under massive DDoS. Our provider can't do anything. What can you do? We can help. They walked them through it with an hour on the phone, included DNS propagation. They basically shimmed CloudFront in front, and the DDoS went away. Everything just goes away because they have 100 points of presence around the world with CloudFront, and it just handles things like SYN floods and bad requests. They just don't get through it. So things like serving a tiny website costs me. I think I serve 5 through CloudFront, and it costs me less than a penny a month, but it gets rounded up to a penny a month. All of that, and I'm going to talk about this part next, all of those are fully TLS, and I pay $0 a month for my TLS. So I'm going to talk about that one next. The big green one behind the CloudFront icon is AWS Shield, which is sort of a new thing. They've sort of broken out into a separate product. Shield Basic, everyone gets for free. Shield Advanced gives you a whole bunch of stuff, including 24/7 access to a DDoS response team. And if, say, you have a core and your web tier scales out to 10,000 instances to handle a DDoS attack, with Shield Advanced, you're not responsible for that scaling cost. Let's say you spent $50,000 extra because you handled a bunch of extra requests that weren't taken care of by Amazon via magic. They look at that and go, yeah, you were under DDoS. Cool. We will just wipe those costs away because that wasn't your responsibility. You didn't get to choose that. So they have a lot of options, a lot of visibility. And if you have Advanced, you actually get visibility into their visibility. So kind of like this, you get a map of what they see the world internet and denial of service traffic looks like from their perspective, and how that might affect you and where trends are going. It lets you plan. It's actually really cool. So I talked about TLS. This is Amazon Certificate Manager. Amazon Certificate Manager lets you issue TLS certificates. You can't use them everywhere. You can only use them on CloudFront and load balancers. But if you have an Amazon site, or you're using CloudFront in front of an on-premise site, that gives you TLS. And you don't have to pay for whatever certificates you're using, and you don't have to worry about the overhead if you're running a site that gets 5 hits a month. Managing a server and the cron jobs for Let's Encrypt and making sure your cron jobs don't fall over is kind of a pain. This is way easier for me, for example. Whether or not it's easier for you is a call that you guys kind of have to make. You can't steal a key that's never given to anything that you can access. So Amazon never gives you keys to the certificates they issue via Amazon Certificate Manager, which is a plus and a minus. It depends on what your requirements are. But for me, that's a big plus. It means I don't have to do key management. That's great. Integrates with pretty much everything. It's just plug and play. You check a box, you say, issue me certificates. Mails show up, you say, I approve, and then the certificate gets issued. Just kind of like Let's Encrypt. You can do it all through the API as well. They have their own CA, and it's free. It's a really nice service for small web properties or other things that you don't want to go through, dev, test, things where they don't need to be part of your real CA infrastructure. It's a great way to take a look at that. Okay, I'm done with the edge. We're moving inside. We're moving closer in, moving to the core, where all of the applications sit, where all the major stuff happens, where everyone gets a web server, and they're probably all in Docker, and they're probably all running as root, and nothing is a problem. What does high availability mean to you when you have an on-premise server? This is an HA pair, by the way. You're welcome. So when you're on-prem, high availability means things like, I got a pair of power supplies, I got a pair of networking, I got some devices, I have 2 of things. It definitely means dual PSU. If you're running a VM cluster, it means you have spare host capacity to move your guests around if a host fails. If you're a networking provider, you may have spare transit providers. You may have spare uplinks. If you're a big place, you may have generation capacity or require your data centers to have generation capacity. HA means a whole bunch of things to a whole bunch of people. So what checkboxes does a single EC2 instance or Azure VM or Google VM check? Well, it has redundant power supplies. There's plenty of spare host capacity to move the VM around. There's redundant transit, redundant power, generation power. It checks pretty much all the things that we would expect from on-prem, and yet it's only one machine. For twice the price, I can just spin up 2 of them. So now I have all of those same checkboxes and a whole bunch more. So this is an example of, and it's, wow, that is atrocious. That's okay, there's going to be red circles, so it'll kind of make sense. Just listen, don't watch. So this is a rough idea of what a highly available and scalable architecture would look like in a public cloud provider. This is Amazon-specific icons, but it works anywhere. You start off with your database. Database, synchronous masters in 2 separate failure domains. You probably can't see it, but there's an orange box and another orange box. Those are availability zones in Amazon. They're called different things in other providers, but they're failure distinct. So you can just grenade one entire availability zone, and the rest will just keep ticking like nothing happened. So you can have synchronous masters across failure domains. Nice. I have replicas in each failure domain. Awesome. All of that is bound together by redundant networking. So your top of rack switches, there's 2 of them. Links, there's at least 2 of them. There's actually many more, but there's at least 2. Your web tier is scalable. I'll talk about that a little bit later. That's all behind some magic elastic load balancer. You don't have to worry about swinging your F5 Viperon around the moon and hope it comes back. You can actually have a load balancer that you can trust is probably going to do okay. Amazon's ELB and load balancer tooling is mostly just pretty wrapping around HA proxy. So that's the magic they do. They just wrap it up and give it to you nicely. Your edge routing is, again, hugely scalable. Most of their regions have 10, 15, 20 or more terabits between them and pretty much anywhere else. So that's something that you get when you want, say, if I have a T2 Nano with 512 megs of RAM and half a core, cool. If I want an instance with 25 gig networking, that means it has 25 gig to the world. It's just something you sort of get. Any sort of DDoS mitigation or protection or firewalling or WAFing, and your edge. So things like CloudFront. So that's all stuff that you get as part of joining like a public cloud ecosystem. And by joining, I mean building your application there, not like a cult, although there is similarities. So this is kind of what it looks like. I didn't touch on this. This will all come later. But this is what sort of the edge and the availability aspects look like when you're looking to deploy an application in public cloud and how it relates to deploying it on-premise. So scaling like Konami code, this is just reference like up, down, left, right. Scaling up, meaning bigger instances. Scaling out, mean more of them. The biggest, who thinks they have a big host, a big single machine, single chassis, lots of cores, lots of RAM? Handful, cool. Is it 128 cores and 4 terabytes of RAM? So that's the biggest shape you can get in Amazon or Azure. Google's is about 700 gigs, 96 cores, but not in the same shape, but they have some things in beta that are happening. So that's the biggest shape you can get. That's the biggest single instance you can get. Okay, that's 280 blue boxes. That's 280 EC2 instances. Each one can have 36 cores. In this case, I'm going to say they have 36 cores. That's 10,080 cores. How much do you think this costs per hour? Any number. Just price is right here does not work, but sure.
5.
Sure. 50 bucks an hour. So 10,000 cores for 50 bucks an hour. Now, granted, this is assuming in spot, but I've actually done the analysis, and as long as you're not super picky, you can be a little bit picky. As long as you're not super picky about where these are, you can always get spot instances for 90% off of on-demand. So when you go to the EC2 pricing page and you say, oh, this instance is going to cost me $1.50 an hour, that's super expensive. Yeah, probably. But do you need it right now, and do you need no one to be able to take it away from you? If you can architect your application in a way that you can take advantage of spot pricing, this is what you get. It's kind of fun. So that covers the availability section in the core for the compute side. So I'm going to talk about the problem we all have. It's okay. We're almost done with the puns. unless I just feel like throwing more out. We'll see. So we all have data. Whether or not it's big data is questionable. I would say most people tend not to, even if you have a lot of data. But managing your data, making sure that it's resilient, it's not going anywhere. What you put there is what you get back. Like that's all tricky. And versioning and backup is hard. RAID is not backup. Specifically tape. I needed some way to represent backup, so I chose some tape. RAID is not backup. So if you're going from your RAID 10 production array to a RAID 60 backup array, cool, great. You have slightly better durability, I guess, but it's also not backup. Like it's not, you can't store things there for the same price as you would store on tape. You can't store the same volume there. Similarly, how do you guys do versioning? If it's like this with PhotoRec, that's not how you do versioning. That's not how you recover a file that somebody accidentally deleted. So versioning your backups, saying, okay, what's the granularity? Well, is it 1 minute, 5 minutes, 10 minutes, an hour, a day, a week? Like, so if I come into work and, Sally from accounting has gone and deleted my entire expense report for the last 6 months. Darn, that took me like a day to put together. I got to do that all over again. How do we restore that? How do we go about doing those kinds of things? And that kind of availability is sort of what we're going to talk about. We'll talk about S3. Who has heard of or used S3? Not bad, about half the room. Cool. S3 is an object store. It's where you put things in and they sit there for almost literally forever. 11.9's durability, which means that if you store 10,000 objects in S3, you can expect to lose one every 10 million years. If you store 1 trillion objects in S3, you can expect to lose one every couple months. Who here has 1 trillion objects? Nice. We'll talk about that later. There are single customers on Amazon with trillions of objects and exabytes of data in S3. So this is all stuff that's managed. This is all stuff that they just provide. And 11.9's is their technical guarantee. I mean, it's like if the whole US government just implodes and it's civil war and all the Amazon data centers in the US go away, yeah, that's a problem, but that's not something they can really control. Sort of, like the data centers in Vegas and their armed guards. Those are just weird. So EBS. EBS is our iSCSI volumes, our block stores. This is what underpins VMs. EBS volumes are like an iSCSI LUN. They sit on a magic storage array that we don't know anything about somewhere. It's pretty cool, and you can take snapshots of them. And those snapshots have 11.9's durability. That means they're stored in S3. Like most of Amazon, stored in S3. Who remembers when S3 and US East 1 went away earlier this spring? And how most of the internet didn't work? And how Amazon literally couldn't update their status page because S3 was broken? Amazon spends a lot of time eating their own dog food, and S3 backs most things, which means for data stuff, that's actually a really good thing. S3 it's magic. Without going into more details, although I'm happy to if you pigeonhole me later, single word, magic. It works great. It's super cheap. Tons of flexibility. So EBS volumes can be backed onto S3, which is great because EBS volumes aren't guaranteed not to fail. A block volume will fail at a rate of about 0.1% per year, give or take. But they assume that you're aware of that and you're going to build your stuff in a way that accepts that. Now, if it fails, it doesn't mean you lose your data, even if you didn't take snapshots, but it does mean that some of it may be unrecoverable. That's really all it means. It'll fall into a degraded state. Usually, once it's degraded, they will restrict your ability to read and write from it. I got to zip through the rest of this. Before you actually lose any data that's on it. So that's how that goes. Glacier, a bunch of people probably heard about this. Glacier is about 1/6 the cost of S3, and it's basically a replacement for tape backup. I can put things in Glacier, and that's where I put stuff that I'm not going to need to touch for a while. Compliance records, backups. My offsite backup, I'm never going to need to touch in case my office burns down. That kind of stuff. Glacier works really well. Again, 11.9's durability. It's designed to be at least as durable as S3, so objects from S3 can move to Glacier without any loss of durability, which is really important for things like business continuity and business risk. Storage Gateway, should go a little quicker now. Storage Gateway is a really slick appliance that you can install as a VM on your local network that basically backs either S3 or EBS as either NFS or iSCSI volumes on your local network. So you can say, give me a 16 terabyte block volume. It says, okay, here's an iSCSI target. And you say, okay, initiator, connect to it. Pass that to a VM. That's your VM, that's your thing. Great. Storage Gateway takes care of storing all that data locally, taking consistent snapshots, and punting those snapshots up to S3, where you can then restore them as an EBS volume. So let's say you're using Storage Gateway, and something happens, whole office burns down. In minutes, you can actually have all those VMs running as EC2 instances based on your snapshots from Storage Gateway. Really neat. Really helps move things like legacy workloads where, yeah, it's an NFS share, but we want our files in S3 so we can actually have durability or access them for processing or something. You can do that with Storage Gateway, NFS shares, and things go right up to S3. It looks just like a file system. Really neat, really slick. Don't use S3 Fuse. Use this. It's free. That should be sort of a theme. Lots of these things I'm talking about are free. Last one, Snowball. Let's say you got 100 terabytes of stuff on-prem and you got a 5 megabit uplink. How do you get it offsite? You call Amazon. They ship you a 100 terabyte thing. You plug it into your network. It gives you an SMB share or an NFS share or an iSCSI target. Or I think it even did AFP for a while, and I hope to bloody hell that it doesn't anymore. But you just copy all your stuff onto it. There's a Kindle as a shipping label, prepaid, and you just drop it off to FedEx Depot and it ships back. And then all the stuff you put on it shows up as either EBS volumes or S3 objects in your Amazon account. Really great for moving either large deltas from offsite or remote locations or any kind of stuff where actually shipping stuff over the internet is just too hard. So I'm going to fly through integrity a little bit. This is obvious. Make sure that the stuff that you put there is what you get back. S3 supports really detailed authenticity management. Every object has an E tag, which uniquely identifies the content, and that's generated by the server side, which says, here's what I found, and here's what you gave me. And what you gave it was all over TLS, because they don't allow HTTP endpoints for most operations. Unlike Azure, who just added HTTPS endpoints for most operations. So, right? Seems like a no-brainer, but apparently not. For best results, use ECC on your client side. The data on your disk might be great, but when you go to actually do things with it and put it back onto the network, doesn't mean that it's going to make it through your non-ECC RAM. It does flip bits, things happen. So for your really critical data, ECC is sort of not a joke. It's worth doing. EBS, depending on how paranoid you are and your snapshots aren't good enough, snapshots are incremental, by the way, so taking multiple snapshots when your deltas are 0 costs you nothing. So you can take a snapshot every 5 minutes or every hour. I take them daily because that's approximately how fast our churn is. But taking more snapshots when your deltas are small, you only pay for your deltas. Really good. If that's not enough, FreeBSD runs great on Amazon, Azure, and Google. OpenBSD runs on Azure. They all support ZFS, production, hardcore stable, have been for years. So if that's a concern of yours, worth looking into. All right. Who gets alerts from operational systems? Handful, 15 or so. How do you authenticate that those alerts aren't an attacker trying to get you to do something? Yeah, the question wasn't whether you do or not, it's how do you? So SNS is Amazon's simple notification service. It's how they do notifications. It includes email, HTTPS, HTTP, post, all sorts of different endpoints, including SMS. When you get an SNS notification, it's signed with Amazon certificate. And they give you the certificate URL and the signature. So that you get a notification, you can go grab the certificate if you don't have it, and verify that the signature matches the notification. And that allows you to actually look at your notification and say, yeah, this is what I expect, which is really important if you're not just notifying people, if you're notifying applications or services or other back-end components with a notification system. It's important those components are actually getting a notification that's from you and not from someone else. So it's a neat little thing that isn't often talked about with, just go, oh, just use SNS. It actually comes with that built in, which is really slick. Audit logs, I talked a bit about all that stuff at the beginning, config, CloudTrail, that kind of stuff. Most of those logs that you get are signed. So CloudTrail API logs are all signed by Amazon's private keys. Public keys are available. So that I can't go and clobber something, I need to actually break the crypto to do that, which is really nice because that means your audit logs are immutable. You can also log to out-of-account resources so that let's say I go and break into John's account, and the audit logs never actually land in John's account. They go somewhere else to a bucket in an actual audit sync where only 2 people in the company have access to it. That really allows you to lock down who has access to what audit logs and actually audit access to the audit logs. Really handy. One thing I'm going to talk about that is kind of unfortunate. This is in red for a reason. DNSSEC is only half supported by Amazon's DNS management tooling, Route 53. You can speak DNSSEC to the CA, but you can't sign queries. Boo. They'll get there. They'll get there. Authenticated identity. Who are you when you're talking to a service? Are you a username password? Are you an LDAP identity? Are you an OAuth token? Like, who and what are you? Amazon handles all of that through identity and access management, which is magic. More magic, but except this time, it really is super great. So IAM has users, groups, roles, and policies. A user is someone like you or I, or it could be an on-premise application that needs to authenticate to the API. A group is a collection of users. A role is what you give infrastructure. So if you have a server that's responsible for, say, polling something and then updating an SNS topic if there's an outage, it would have a role because it's not a person, unless it's on-prem, in which case it's a person. Pets, not cattle, right? And policies are what you actually use to grant permissions. You can be so incredibly granular with these kinds of policies and permissions. I can say a user has access to exactly one object in an S3 bucket. And it only has access to it if the request is coming from this IP address during these times of day, and their API keys have been used or they have authenticated with MFA. So you can do all sorts of really fun stuff. You can actually authenticate to things like MySQL with IAM. So you can use one authentication mechanism for a bunch of stuff. DynamoDB, which is their managed NoSQL database, lets you control access based on content in rows. So you can say you're allowed to get any item in this database except for rows that have credit card number field or name field or something like that. Really neat. So there's API keys, web console logins, temporary credentials, MFA tokens, all part of IAM. So infrastructure has an identity. Whether or not we want to admit it, our infrastructure elements have identities. And you can call them whatever you want. You can give them whatever permissions you want. You can do all of that through IAM. And if you're doing it in Amazon, you can actually do it in a way that they'll manage it. Don't tempt fate. If you want to call a role HAL and then give it to an EC2 instance, I make no promises that people won't look at that and go, hey, that looks fun, and then change the role and then bad things will happen. I've seen that. When you give roles to your instances, again, it's all still logged in CloudTrail. Confidentiality, I really need to go faster. KMS and you, what's the hardest part about cryptography? Travis will say it's passwords. I would say it's key management. Manage your keys. How do we keep track of security keys? That's where Amazon provides KMS, which is their key management service. And for everything except the most end-of-the-world scenarios and the most paranoid situations, KMS is good enough. It's actually good for almost every regulatory situation. And when it's not, they have Cloud HSM, where you actually get third-party hardware security modules, and you get TLS authenticated access to it using PubKey. So it's really neat. They give you two options. Cloud HSM was actually initially requested by Shell and EU financial institutions to get around regulatory requirements, so that they could host things like EU financial data in the US, and they would use HSMs located in the EU. So that's the kind of use case this was at. And you can now, any one of us can actually spin up two of them, and they're literally just billed hourly. I think it's $1.60 an hour US, $2 an hour US if you want them in Canada. And anyone has access. These are like $50, $70, $100,000 appliances. So this is what they give you access to. If you want to talk to the Cloud HSM support team, they have a PGP fingerprint they'll give you and a public key, and all emails with them are PGP signed. So that's the people that you're talking to. Really neat. This is how you encrypt data at rest, right? Data is most secure when you can't use it. For those that couldn't see it, that's a chop saw on a hard drive. So because I want to get some questions in and I'm running out of time, I'm going to zip through this one. S3 has a bunch of different encryption options. All of them have different ups and downs and trade-offs. So you can do unencrypted. That's clearly the most best way to do things. That's right, most best. SSE AES 256 is basically, I want this encrypted on disk. I don't care how. Amazon, you take care of it. That's what this is. SSE KMS is, with the default key is, okay, I want to be able to control access, but I don't care about inside my account. Anyone inside my account can use it, but outside my account, no go. That's what this is. KMS with the non-default key is, I want explicit, specific individuals or identities to be able to access this data. And it's encrypted on disk. That's what this is. And SSEC is, I want to control my own keys, I want to control my own algorithms, but I want you to do all the operations. So I include a key and an algorithm with every operation, And as long as that matches the metadata Amazon's kept about that object, they will encrypt/decrypt the object for you and then give you back the decrypted content. And then for those that really, really don't want Amazon to have access to anything, just encrypt it yourself and send over a blob. Obviously, that's always an option. VM encryption, there's a couple interesting items here. EBS volumes support server encryption by the host. So you can use KMS to use key management, and they'll encrypt the volumes, basically zero performance penalty to your guest. You can do EBS encryption in the guest with VeraCrypt or DMCrypt or whatever you want. EBS snapshots are encrypted with KMS if your devices and volumes are encrypted. In Azure, it's in preview right now, but if you're a developer and you're familiar with Intel SGX is basically a small slice of RAM where the encryption boundary is the CPU die. So on my laptop at home, it's 128 megs, and I can basically ask the SGX libraries to say, hey, give me a small slice of RAM, but CPU, make sure everything you do in that RAM doesn't leave the die unless it's encrypted. And Azure has this in preview. It's secure private cloud computing or something. I forget what they call it. But it's basically SGX in the back end. Actually really cool. AMD's new server processors involve secure encrypted memory and secure encrypted virtualization, which basically does that for the entire body of RAM, which means that a cloud provider that uses these would have, unless they're basically hacking the firmware, have no idea what instructions are going on and what's stored in RAM. Even if they had root on a hypervisor escape, that would just give them a giant encrypted blob. Encrypting everything else. If you use SQL or Oracle, you can do transparent data encryption directly in Amazon. Durable queues like SQS, encrypted. Environment variables, all sorts of fun stuff. I don't know why I did that. And KMS keys and CI/CD pipelines. Managing scope and blast radius, I'm going to, no. Okay, fine, we'll do this one. Then we're going to go to the end, and I'm going to do questions. So network segmentation is really important. Network segmentation in Amazon starts with a VPC. You can peer that VPC with other VPCs. Those other VPCs can even be in other accounts, or someone else's accounts. When you like, someone you don't like, you get to control that access. Failure zones are subnets, and those subnets live in availability zones. That's really cool. Every subnet has a routing table, so you get to control how each subnet is routed. You can send them to different NAT gateways or out different VPNs if you like. EC2 instances live in there, and all the routing is handled just sort of via magic. EC2 instances live in security groups. Nice thing with this, it's big different and happy accident of software-defined networking, is security groups can have as source or destinations other security groups. So if you have two sets of elastic gear, elastic workloads, they can talk to each other and you don't have to worry about too much. Routing, networking, edge, all magic. And that's all, of course, you actually get flow logs on it. So something like, random pip packages ended up and you want to know whether or not your developers have been installing them. You just troll through your flow logs for the last 6 months and figure out whether or not any of those IP addresses showed up in your flow logs. And yeah, the rest of this I'm going to skip because I want to get to questions. These are my cats. So thanks for your time. Sorry I kind of ran out of time. I think I have a couple minutes. And if you want to ask a question but aren't sure, let's start. Anybody have a question right now? 1, and then 2, and then 3.
You mentioned like S3 container basically open never. What if you got not retention, but like unique different files? Like you have to come up with now you have S3 unique different file and you make sure that it's removed everywhere from your system. You cannot recover it or legal for you.
So depending on what, the question is, I mentioned that S3 is highly durable. The question was, what if you need something to be indurable? Like I'm at a point, and for whatever requirement, I need to shred a file, and that object lives in S3. Is that correct? Yeah. So the why and whether or not just deleting the object is going to be sufficient is going to depend on the why. If, for example, it's the extreme case, then you would have already had something like Cloud HSM, and that object would have been encrypted with a key that lives on the HSM, and you would just delete the object. And no one else except you has access to the key material on the HSM, and no one would have access to the data without that key. So you would just shred the object, shred the key, boom, done, problem solved. So that's sort of the extreme case. But in almost all cases, KMS is sufficient. And it's way, way cheaper. Costs you $1 a month for a key. And that allows you to basically say, Amazon's compliance and attestations are good enough, so they can technically get access to your key material in KMS, but they need a judicial order and 2 separate employees to unlock your key material. And only then could they access any objects you have. But if you delete an object, they're probably already reallocating those bytes to someone else. So it's sort of like the answer really depends on the why. But there is an option for the extremist case, which is no one can have access to the content or the key material. I have to control both. There is an option for that. Is that kind of? It's wishy-washy without talking more about why. Yeah. There's a. You then, Jared. So the question was, Amazon provides lots of building blocks. When are they going to start providing actual solutions? Is that sort of the high level? Never. Amazon's goal is not to provide solutions. They're there to provide building blocks to let you build solutions. You see more and more of this not being true with things like Google App Engine or Elastic Beanstalk, where they provide a much higher level service, or taking it to the current extreme, which is things like Lambda, which is Google Cloud Functions, Azure Functions, or AWS Lambda, where I literally write Python code and then let them handle everything required to run that code. But as far as full business applications, like we'll make it PCI DSS, I mean, that's almost impossible to provide a generalized framework in which you can make anything PCI DSS. It's notable that not all Amazon services have the same certifications and attestations in all regions. So if I'm in US East 1, maybe I get it. If I have the same architecture in, say, Mumbai, I may not get it. It depends, and that largely boils down to regional governance requirements for the region, the country, or the jurisdiction the region lives in. You'll see more. So that's the long answer. The short answer is a little bit, maybe, soon, sort of. Not a great answer, but top. Jared? Absolutely. So let's say you're doing, they don't do WebSockets. So let's say you want to do TLS wrapping of any of your internal stuff, any of your internal host-to-host communication. You don't have access to key material. You can't set up TLS sessions with those keys. So it really is only for content serving, because you can only attach it to CloudFront or load balancers. Yeah. So absolutely, there are reasons why it's not something that people would use. These are questions I had sort of pre-primed. If any of these are of interest to you, I think Rob's about to cane me off the stage.
This is the most hour, so you can't keep them still that.
Okay. Well, if you guys are interested, and any of these seem super interesting, ask him now until he drags me off. Serverless. Serverless is great. Serverless is someone else's computers. Serverless is by definition multi-tenant. When I asked an AWS guy last year at reInvent, so how does Lambda work? His exact words were, well, I can't tell you, but it starts with contain and ends in So let's pick on Lambda, for example. It is sort of the epitome of serverless stuff. You just write code, and code runs, and it's magic. It's actually highly controlled Docker containers or some other container framework that they do all the magic for. So you can supply a zip file, and they'll explode it. There are limits on how they explode it. But if there's a container runtime exploit, it's possible you could move from your Lambda function to someone else's. But they're ephemeral. they're also not guaranteed to live past one request. So how much that's a big deal starts to get really interesting, because if I have a container that lives for 75 milliseconds and then a new one starts and also runs for 75 milliseconds, how can I persist an attack? Right? And how can I figure anything out if I have to do scanning and also do something but not have any of that interactive and have a runtime limit of 7 seconds? So serverless gets really interesting. It is by definition multi-tenant. It's going to be very interesting to see where this goes and how it makes its way into other regulated environments. Hypervisor compromise. Glad you asked. So Zen has had two major vulnerabilities in the last year and a half-ish. Amazon has claimed not vulnerable to both. And one was due to the fact that it was in the floppy driver, and you don't get a floppy drive. Cool, 1 minute, I can do this. The other one is due to how they use stub guests in Zen setups. So if you escape, you jump into a smaller outer ring of your hypervisor, but get nowhere. You just control your own guest, which you already could do. Big whoop. Amazon has lots and lots and lots of control over the source code for their version of Zen. They own several of their own silicon and chip manufacturing companies, including networking gear, and others they won't disclose. They also build all their own boards from scratch. They get the chips from Intel. Those chips go to another manufacturer. The boards they use are not the boards you or I would buy or get from any other OEM. So hypervisor escapes get really funky because we don't actually know what sort of magic they're doing to protect against it. Talking about that really quickly, I've never been able to exploit Rowhammer despite trying pretty hard on an EC2 instance. So anyway, I think I'm done because Ron gave me 1 minute, and that's my 1 minute.